So we're going to start Chapter 7 on absolute value graphs and reciprocal graphs. We'll start by looking at the definition of absolute value. So for a real number a, the absolute value is written as, and then you see these two little bars on either side of the a. Those are your absolute value brackets. So as absolute value a and is a positive number. Two vertical bars around a number or expression are used to represent the absolute value of the number or expression. And don't get them mixed up with the numbers 1 and 1. It's not like you have like 1a, 1. Okay, like these brackets are bigger than the numbers. Okay. So for example, the absolute value of a positive number is a positive number. Okay, so if you take a look, we have the absolute value of positive 5, that's equal to 5. The absolute value of 0 is 0. And so you put the bars on either side of the 0. Absolute value of 0 equals 0. The absolute value of a negative number is the negative of that number resulting in the positive value of that number. So if you want the negative or the absolute value of negative 5, then that's the negative of negative 5. And remember, a negative times a negative makes it a positive, so it's equal to positive 5. Absolute value can be used to represent the distance of a number from 0 on the number line. Okay, so if we take a look at the number, let's say that our number a is negative 5, then one way that you can think about the absolute value of negative 5 is how far is that number away from 0? And it would be 5 units away from 0, so the absolute value of negative 5 is 5. And then let's say that a is equal to positive 5. Well, then the distance between 0 and 5 is 5, so the absolute value of positive 5 is equal to 5. In general, the absolute value of a number, a real number a, is defined as, okay, and it can be written like this. The absolute value of a is equal to a if a is greater than or equal to 0. The absolute value of a is equal to negative a if a is less than 0. All right, and we're not going to put less than and equal to 0 on this a here because we already have the equal sign on this one. Okay, so I'll split this up and show you with an example. If a is greater than and equal to 0, then the definition of absolute value is that the absolute value of a is equal to a. An example would be, let's say that a is equal to 5, then the absolute value of 5 is equal to 5. Okay, the other half of the definition says this: if a is less than 0, then the absolute value of a is defined as negative a. An example, let's say that a is equal to negative 5, then the absolute value of negative 5 is equal to negative 5, which is equal to positive 5. Okay, so as can be seen from the above definition, the absolute value of a is always either positive or 0, but never negative. Okay, so let's try evaluating some numbers. So determining the absolute value of a number, evaluate the following. So we want the absolute value of 3. Well, this means that a is equal to 3, okay, and so we know that the absolute value of a equals a for a is greater than or equal to 0, okay. So that means that the absolute value of 3 is equal to 3, okay. Now if we want the absolute value of a negative number, then let's remember that by definition, the absolute value of negative a, the absolute value of a is equal to negative a for a is less than 0. Okay, and a in this case is negative 7. So the absolute value of negative 7 is equal to the negative value of negative 7, which is 7. All right, now I wouldn't do that all the time. I mean, I would just write this, negative 7. Absolute value of negative 7 is 7. Okay, but just to show you how it works with the definition. Okay, so try out the next two on your own. Okay, so put the pause button on and try these ones out yourself. Okay, so the absolute value of 9 then is equal to 9, and the absolute value of negative 12 then is equal to positive 12. Okay? Example 2. Compare and order absolute values. Write the real numbers in order from least to greatest. So we're going to take these numbers here and we're going to order them from the smallest number up to the biggest number. The first thing we're going to do is evaluate each number and express it in decimal form. Alright, so our first number is the absolute value of negative 6.5. So remember, the absolute value of any number has to be positive, so the absolute value of negative 6.5 is 6.5. Okay, 5 is already evaluated. The absolute value of 4.75 is positive 4.75. And then we have negative 3.4. Okay, now the absolute value of negative 12 over 5 is the same as the absolute value of negative 2.4. And so the absolute value of negative 2.4 is positive 2.4. And then we have the absolute value of negative 0.5. So remember, we have to come up with a positive number, so 0.1. And then we have negative 0.01. And then the absolute value of negative 2.5 is the same as the absolute value of negative 2.5. And so the absolute value of negative 2.5 is 2.5. Okay, so we want to order them now from the least number to the greatest. Okay, so the smallest number here is negative 3.4. So we put that first. And then the next number is negative 0.01, right, because it's closer to 0 than negative 3.4 is. And then 0.1, and then 2.4, and then 2.5, and then 4.75, 5, and 6.5. So now we want to show the original numbers in order from least to greatest. Okay, so negative 3.4 was already negative 3.4, and negative 0.01 was already negative 0.01. The 0.1 we got from the absolute value of negative 0.1, so that's what we're going to put here. So absolute value of negative 0.1. And then our next number is 2.4, which we got from the absolute value of negative 12 over 5. So we'll put that next. And then our next number is 2.5, which we got from the absolute value of negative 2.5. And then the 4.75 came from the absolute value of 4.75. And then the number 5 is next. And then the 6.5 came from the absolute value of negative 6.5. Okay, so the next question is for you to work out. And so put pause on and try to do it on your own. Okay, so the answer for this, well, I guess I'll go through the solution with you. You should have 3.5, negative 2, 5.75, 1.05, 3.25, 0.5, negative 1.25, and 3.3 repeating. Okay, so order it from least to greatest, so negative 2, negative 1.25, 0.5, 1.05, 3.25, 3.3 repeating, 3.5, and 5.75. Okay, and the original numbers are -2, -1.25, absolute value of -0.5, 1.05, absolute value of -13/4, then the absolute value of -3 1/3, and then absolute value of 3.5, and then the absolute value of -5.75. Okay. So now we're going to evaluate absolute value expressions. So absolute value symbols should be treated in the same manner as brackets. Okay, evaluate the absolute value of a numerical expression by first applying the order of operations inside the absolute value symbol and then taking the absolute value of the result. Okay, so let's evaluate the following. We have on the first question the absolute value of 4 minus the absolute value of -6. Okay, so think of these as brackets, even though they're your absolute value symbol. You're going to evaluate there first. Okay, so the absolute value of 4 is 4 minus the absolute value of -6 is +6. So you can write 6 and then 4 minus 6 is -2. Okay, on B, think of this as brackets. All right, and then you're going to go 5 minus 3. And you're going to go absolute value, and 2 minus 7 is -5 absolute value. Okay, so we're first going to finish what's inside the bracket, and then we will work with that now. Okay, so now what we want to do is calculate the absolute value of -5. Okay, so that will be 5 minus, and then remember, when there's no sign between a number and a bracket, that means multiplication. So we're going to go 5 minus 3 times 5, because the absolute value of -5 is 5. And now we will complete the question. We'll go 5 and then minus 3 times 5 is -15, and then 5 minus 15 is -10. Okay, now the next question, the whole thing is inside the absolute value symbol. So you're going to evaluate everything inside first. Okay, so do your orders of operations, and then the last step you will be calculating the absolute value of the number. Okay, so we're going to go -2, and then we have 5 minus 7 in a bracket there, and 5 minus 7 is -2. There's a square on the outside, plus 6. Okay, and then absolute value, you've got -2 times, okay, -2 squared is 4, plus 6, absolute value sign, then absolute value sign, -2 times 4 is -8, plus 6, absolute value symbol, and then the absolute value of -2, because -8 plus 6 is -2, and then the absolute value of -2 is +2. Okay, so you're going to apply your order of operations inside the bracket. Okay, now on your next page you'll have 3 questions to try on your own, so put the pause button on and work them out. Alright, so on the first question, absolute value of -4 is 4, minus the absolute value of -3 is 3, 4 minus 3 is 1. On the next question, you're going to simplify what's inside your absolute value brackets first. So you're going to have the absolute value, and then -12 plus 8 is -4. And so the absolute value of -4 is +4. Okay, so remember, the absolute value of a negative number is always positive. Okay, and on this one here, you're going to evaluate everything inside the bracket first and work out the absolute value at the end. So use your order of operations inside the bracket. So 12 times -3 is -36. And then plus 5 squared is 25. So evaluate that. -36 plus 25 is -11. So now you're looking for the absolute value of -11, which is 11. So this last example in this section will be a word problem where we will be taking a look at the change in stock value. So on stock markets, individual stock and bond values fluctuate a great deal, especially when the markets are volatile. A particular stock on the Toronto Stock Exchange, the TSX, opened the month at $13.55 per share, dropped to $12.70, increased to $14.05, and closed the month at $13.85. Determine the total change in the value of this stock for the month. This total shows how active the stock was that month. So the word total suggests that we're going to be adding. And what they mean by the total change in value is if we take the difference between $13.55 and $12.70, and then $12.70 and $14.05, and then $14.05 and $13.85, and we add all those differences up, that will give us a total change. So we're going to calculate using a little formula here, the absolute value of V subscript I plus 1 minus V subscript I, where I is equal to 1, 2, and 3. Now, the reason why we have values for I that are 1, 2, and 3, because we are going to take a look at 3 different changes. Okay, we want to take a look at the change between $13.55 and $12.70, and then $12.70 and $14.05, and then $14.05 and $13.85. Okay, so we're going to let V1 be $13.55, V2, okay, so the value, our first value is $13.55, our second value is $12.70, our third value is $14.05, and our fourth value is $13.85. Okay, and we are going to calculate each change in stock value and find the sum of these changes. Okay, so we're going to use our formula. Okay, and we're going to substitute in values for I, 1, 2, and 3. So for the first one, the absolute value of V, and we're going to plug 1 in for I, so we're going to have 1 plus 1 is 2, so that'll be V2 minus V, and we'll plug 1 in for I here, so V1. And then add that 2, and now we're going to substitute 2 in for I, so we're going to have V, and then subscript 2 plus 1 is 3, minus, and then plug in 2 for I again. And then the last one, we plug in 3 for I, so we get V subscript 3 plus 1 is 4, plus V subscript 3. Okay, and then we will substitute our values in. Okay, so V2 is 12.70 minus V1, which is 13.55, plus V3, which is 14.05, minus V2, which is 12.70, and then plus V4, which is 13.85, minus V3, which is 14.05. So you can see that each of these parts are the differences between our stock value as it fluctuates. Okay. All right, so we'll calculate the totals in each absolute value bracket. So on the first one, 1270 minus 13.55 is negative 0.85, plus, and then 1405 minus 1270 is 1.35, plus, and then 1385 minus 1405 is negative 0.2. Okay, and now we calculate the absolute value of each of these numbers. So we're going to have the absolute value of negative 0.85 is 0.85, plus the absolute value of 1.35, which is 1.35, plus the absolute value of negative 0.2, which is 0.2. And then when we add them all up, we get 2.40. So the total change in stock value for the month is $2.40. Okay, so let's take a look at the right here. Does the order in which the values are subtracted matter? Okay, well, let's take a look. If we, and we'll just take a look at this first one here. Okay, so we'll look at this, okay? So we know that 12.70 minus 13.55 will give us absolute value of negative 0.85, okay, which we know will give us 0.85. Okay, so let's reverse that then. Okay, so let's say we're going to go 13.55 minus 12.70. That gives us the absolute value of 0.85. And the absolute value of 0.85 is 0.85. So does the order in which the values are subtracted matter? No, it doesn't. Okay. All right, and the next thing, did you know? Calculate the net change of a stock as the closing value of the stock minus the opening value. Okay, so net change is something that's a little bit different, or actually it's quite a bit different than when we're looking at the total change in the stock value. The net change just means take the difference between what the value is at the close of the month, okay, and the value at the opening of the month. Okay, so what does it open at? So it opens at the start of month. Okay, so we know that the stock is worth $13.85 at the end of the month and it's worth $13.55 at the beginning of the month. So we just take the difference of those two numbers and the overall change in the month is 0.34. Okay, now how does that compare to the total change in stock value for the month? Well, this number here tells you, you know, if the stock, like we started at $13.55, okay, $13.55, it went down to $12.70, and then it went up to $13.85, sorry, $14.05, and then it went down to $13.85. Okay, and so what we're calculating here is what is the difference between all these ups and downs. Okay, and this one here just wants you to give the difference between what's the value at the beginning of the month and what's the value at the end of the month. Okay, so that ends our section 7.1.